Hello students, let us discuss oxidation states in 15 group elements. As p block elements shows variable oxidation state, so it is need to discuss the oxidation states for 15 group elements. Let us take some examples of compounds of nitrogen. Here are ammonia, N2H4, NH2OH, N2, N2O, NO, N2O3, N2O4, N2O5. These are the different examples of compounds of nitrogen, that is ammonia, hydrazine, hydroxylamine, nitrogen molecule, nitrous oxide, nitric oxide, nitrogen trioxide, nitrogen tetraoxide, and nitrogen pentaoxide. When we find out the oxidation state of nitrogen in these compound, it will be in this way. What it shows that the nitrogen forms the oxidation state that is -3 to +5. So, the possible oxidation state for 15 group elements are -3 to +5. The maximum oxidation state for 15 group element, that is +5, which can be calculated by the formula, that is the group number, that is 15 minus 10, that is equal to +5. So the maximum oxidation state +5 can be calculated by the formula, that is group number minus 10, that is equal to +5. So the highest oxidation state for 15 group element is +5. But the elements of group 15 generally exhibit -3, +3 and +5 oxidation state. When we compare the electronic configuration of these elements, from this it is clear that these elements have 5 electrons in the valence shell because of the configuration NS2 NP3. Therefore, it requires 3 more electrons to acquire stable configuration. But the gain of 3 electrons is not energetically favorable because it requires very large amount of energy to gain 3 electrons and form 3 negative charged ion. However, nitrogen being the smallest and most electronegative element of this group, therefore it forms nitride ion. So it shows the oxidation state -3 in nitride of some highly electropositive metals such as magnesium, calcium, etc. But the other elements of this group form covalent compounds with the metals and show -3 oxidation state. Example, calcium phosphide, sodium arsenide, etc. So, what it shows that for -3 oxidation state, we can say, for example, in the case of ammonia, nitrogen have -3 oxidation state. So from this we can say that the tendency to exhibit -3 oxidation state decreases as we move down the group due to the increase in the size of the atom and the metallic character. As we have discussed, nitrogen being the smallest and the most electronegative, it shows -3 oxidation state. But this tendency, that is, in order to form the oxidation state -3, this tendency decreases down the group. Because when we moving top to bottom, the size of the atom increases and the metallic character increases. Metallic character increases means the tendency to form minus oxidation state decreases. So we can say that the element like bismuth hardly form any compound in the oxidation state -3. But nitrogen can form many compounds in which it have oxidation state -3. So that is the most general oxidation state exhibited by the elements of group 15, that is -3 oxidation state. Let us discuss +3 oxidation state. +3 oxidation state, it shows +3 oxidation states also. But the tendency to show +3 oxidation state increases as we move down the group. That is due to inert pair effect. When we move down the group, because the metallic character is increases, so it shows greater tendency to form positive oxidation state rather than the negative. So it can show the positive oxidation state also, and the tendency to exhibit +3 oxidation state increases as we move down the group, that is top to bottom. So when we compare any examples of the compound in which these exhibit +3 oxidation state, usually the lower members like arsenic, bismuth, antimony, these shows greater stability towards the +3 oxidation state than the nitrogen and phosphorus. When we compare the oxidation state with +5 oxidation state, we can say that the stability of +5 oxidation state decreases down the group. So, when we compare the oxidation state +3 and +5, top to bottom, the stability of +5 oxidation state decreases, but the stability of +3 oxidation state increases. Let us take an example. When we compare the stability of NCl3 with SbCl3, which one shows greater stability? So what is the oxidation state of nitrogen here? That is +3, and here the oxidation state of Sb is +3. So in both these cases the oxidation state is +3. So as we have discussed the oxidation state +3, its stability increases down the group. Since this is down to nitrogen, so we can say that top to bottom the stability of +3 oxidation state increases. So that means this one will be more stable in compared to NCl3, because due to the inert pair effect, the tendency to exhibit +3 oxidation state increases as we move down the group. That is due to inert pair effect. But the stability of +5 oxidation state decreases. But nitrogen and phosphorus also show +4 oxidation state. So when we make an example here, that is ammonia with the reaction with the Lewis acid, it results in the formation of a compound ammonium borotrifluoride. So this result because of there is a formation of a bond which is called as a dative bond. That is a coordinate bond here. So because of the presence of the lone pair on the ammonia, it formed dative bonds with the Lewis acid BF3. So because of this reason, we can say that nitrogen can exhibit or shows +4 oxidation state. So from this, we can conclude that the general configuration of these group element, that is NS2, NP3, the common oxidation state are -3, +3, +5, and the stability of +5 oxidation state decreases as we move down the group, and the stability of +3 oxidation state increases as we move down the group, that is due to inert pair effect. So this is all about the oxidation state. In this video we have discussed It is one of the most important point in order to discuss its chemical properties. So this is all about this video. Have a nice day.